Okay, perfect. So welcome everybody. I will do a short introduction. So Alisa Rod is the research data management specialist at the McGill University Libraries, where she provides individual consulting to campus researcher and research groups on the fundamentals of research data management issues, including data management planning, funding agency requirements, data citation practices, open data, and research data lifecycle management. Alisa also helps researchers publish data with McGill's institutional research data repository. She has a master's in information studies degree from McGill and another master's and PhD in political science from the University of California at Santa Barbara. Welcome and thank you so much for presenting today.
Hi, thank you so much for having me. So I'm gonna just dive right in. I think there
Yes,
should be enough time at the end for questions if anyone has any questions. Let me do this. All right, so I'm just gonna cover what is research data management so we're all on the same page of what that means precisely. What's the regulatory context we're working in? So of course, in the hospital setting and the clinical setting, there's a lot of layers of regulatory context that we have to think about when we're managing or working with research data. So particular focus on thinking about how to manage sensitive research data. And of course, we have different notions of what is sensitive in different contexts. I'm going to talk about at the end of a project, how we can make data fair. So these are the sort of best practices that are coming out around sharing research data with other researchers or the public. And this has a lot to do with the idea of being transparent about data collection methods and results, as well as sort of contributing back to the pool of data that's out there for other folks to innovate on. Um, so basically, what is research data management? So it encompasses a lot of activities, but it's very specific about the research data that's being collected or used or analyzed in a project. So it's less about the project management itself and more about the management of just the data. So thinking about data as its own kind of asset during a project. Um, so it's thinking about the activities involved in planning for the collection or creation of data. So all things like even doing an ethics application. What does that entail? Where are you going to store your data? How are you going to analyze it? Who's going to have access to it? What are you going to do at the end of the project? So a lot of this is to set folks up so that at the end of your project, you're able to commit to doing something with the data, and you've set yourself up to be able to do that. So whether that's keeping it, just retaining it for some number of years, or whether that's sharing that with other researchers, or the public, or the folks who might be interested in this kind of research or data that come out of a project. It's setting yourself up so that you're able to do that in an efficient way without wasting a lot of time or having to backtrack and go through more processes at the end of a project. It's also about thinking about especially digital data and how those can be preserved over time and retained. So there, as we're collecting more and more data, this is becoming really challenging, I think, for a lot of researchers. So what are the benefits of good research data management? So first of all, it's useful. It's like project management. It's for your own benefit, right? It's if you're organized, then you can more efficiently find things, you can more efficiently share information. It's easier to onboard trainees or other collaborators to projects when everyone is sort of on the same page about how everything is going to be organized and what are the processes in place and the workflows in place for dealing with the data itself. Um, there's although other kinds of incentives as well. So for researchers, there's some research on publishing data or making data available according to the FAIR principles, which doesn't necessarily mean openly publishing it. So closed or controlled access data fall into this bucket of FAIR data, which I'll talk about a bit later. But there has been some research showing that this increases the impact overall of the research that comes out from these projects. So when the data are available or when other folks can find the data, this increases the citation impact of related articles by as much as like 25% in a study that was done in 2020. So this could be even higher at this point now. Um, it also increases confidence and trust in research. So there's been a lot of misinformation out there about, just everything, but about research in general and science in general. And there have unfortunately been some very high profile cases of fraud in science in the last decade or so, or more of this has come to light as folks have been able to verify findings by data that are published. So it's become less acceptable to guard data and not share it with others, especially when they want to verify someone's findings in a paper. And so by aligning your research data with the FAIR principles and by making it as openly available as it can be within a given context, this helps to increase trust in research overall. And now there are also a lot of funder and journal mandates related to research data management. So now these things are sort of being mandated by funders themselves, and also journals have stricter policies around data sharing when someone wants to publish in those related journals. So just quickly, I'm going to go over like what's the context we're working in when we're talking about managing research data. So we have a lot of layers of both bureaucracy, policies, and sort of regulatory and legal layers when we're working with data, especially in contexts involving health information. So there's a lot of things going on. There are institutional policies. So if folks have joint appointments at McGill or are working on a team where they are also McGill affiliated, then all the institutional policies at McGill apply. Then you have your local institutional policies that apply. So for example, at McGill, we have a cloud directive that sort of has some information about or some restrictions on where data can be stored and at what level of sensitivity they can be stored in terms of third-party cloud services that haven't been vetted by McGill's IT security unit. We also have a conduct of research involving human participants policy. We have a conduct of research policy regulation at McGill. Then there are, of course, hospital policies as well. There's also another layer of funder policies. So the tri-agencies, including CIHR, have pushed out an RDM policy over the last few years. So they're sort of phasing it in over time, and they're at the last stage of it, which is the data deposit requirement. So I'll talk a little bit about that as well. But that's going to have some implication for folks who are funded by those agencies. Also, the NIH in the United States has stricter policies around data management and sharing that they introduced in the last couple of years as well. And then there's also legislation, which I won't go into because that's not my area of expertise, but just wanted to mention that there are a number of laws related to safeguarding personal information that have implications for research as well. And when we're talking about personal information in that kind of regulatory context, we're talking about information in Quebec, at least, that directly or indirectly identifies people. So that actually broadens the scope quite a bit on what information is considered sensitive. So in the past, I think it had been quite common for folks to de-identify their data and say, okay, it's de-identified, now it's not that sensitive. But unfortunately, within this scope, thinking about indirectly identifying information, we have to be a lot more careful about what we're saying is anonymized or not, or just de-identified. And there's an extra layer of this for sensitive personal information, which includes things like health information. So just a quick differentiation between de-identification and anonymization. So for de-identified personal information, and that includes personal health information, it's still personal information. So in the context here, if it's de-identified, it's still personal information. It's not considered anonymized. So it just means that you can't easily identify a person, but it doesn't mean you wouldn't be able to if you tried really hard. And it means that you've taken reasonable measures to limit the risk of re-identifying the person. So this could mean like if you're collecting information that has demographic variables or information related to folks, to participants, that you've removed some of that information, but not all of it. So combining some of that information, it might be then possible to re-identify people. This is in contrast to anonymized information, which is irreversible. It means there's no key or code that you're retaining that can later be used to re-identify participants. So I think in a lot of practice, in the past, we were able to sort of keep a code, keep our data set with the participant ID, and then because they're separate, say that data set is anonymous, but that's no longer the case. So especially in Quebec, there's a sort of part of Loi 25 or the Access Act, there's been an amendment that talks about anonymization in particular, and they're very clear that it has to be irreversible, meaning you can't then reattach it back to a code containing someone's personal information. Um, if it is completely anonymized, though, then it is no longer considered personal information and then doesn't meet that threshold of having to be safeguarded in the same kinds of ways. So just an FYI for that. And I wanted to talk a little bit about the tri-agency policy as well. So what they've started to do is implement requirements for data management plans. This started in 2022. So they're asking for certain funding opportunities for researchers to write a data management plan and submit it when they're applying for a grant. So that will lay out how you're going to manage your data throughout the project. And then the upcoming requirement is data deposit, which we are expecting it to roll out this year, and it would affect future grants. So it's not retroactively applied. It would only apply to grants that are awarded after this comes into effect. The timeline I've heard is that they're still aiming for by the end of this year. I think right now they are going through the approvals process for some clarification documents around this part of the policy. So they have an FAQ and some clarifying language for the policy. And that's going through the internal approval process. And they're hoping to sort of have that publicly available by the summer so that researchers can see this and see what's coming. And then they hope to implement that by the end of the year. Of course, with the tri-agencies, sometimes these things get pushed back, but it is on its way. And in terms of what is the data management plan for that part of that requirement, it's a document. It's usually 2 to 3 pages. It's meant to sort of outline the tools, methods, and procedures that you're using for managing research data. And it's a plan for both when you're actively collecting data, when you're working on the project, but also importantly, what you're going to do with the data at the end of the project. So all those things are meant to be really cohesive in a good plan, right? So you're working on it in a certain way and you're managing the data in a certain way with very detailed kinds of practices during the project so that at the end of the project, you're prepared to do whatever it is you need to do with the data at that point. When you're using it as sort of an internal document, it can be sort of a living document. It can be updated over time. It's not like an ethics application where you're sort of stuck to what you've said. It's really meant to be a plan and to show that you have some have thought about these things in advance, essentially. So I just wanted to show an example. So I know CIHR has been rolling these out more so than the other two funding agencies out in the tri-agency. They've implemented them for, I think, all clinical trials. They've asked for these, and now they're starting to roll them out in other programs as well. So here's just an example of what they said a couple years ago, which they wanted people to describe what data are going to be collected, acquired, how it will be documented, formatted, protected, preserved, where it will be deposited, and how it will be shared within and outside of the network. So they really wanted people to speak about this idea of like, at the end of my project, how will other researchers gain access to it? And if they won't, what are the justifications for that, right? What are the ethical or legal or commercial restrictions around that data that prevent it from being shareable? So that's something that's fine, but has to be discussed in these plans. And they encourage folks to use the DMP assistant to create their data management plans. This is a sort of online template tool where you can work in the browser and sort of write your plan. And I just wanted to make a note that I've worked with the RI at the MUHC to develop a template for medicine and health sciences. And so it has McGill specific guidance, which some of that might make sense for the hospital context as well, and some of it might not, but at least you can see what the guidance is. And a lot of it is about, what are the storage options we have available at McGill. So having very specific details about if you're a McGill affiliated researcher, what do you have access to and what should you say in specific parts of the template? So I've linked that here, and of course I will share my slides so you'll have access to that as well. It's built into the tool, so if you sign in saying McGill is your university, which you can do, anyone can sign up and say and associate themselves to McGill. You will have access to the template when you're creating a data management plan. Okay, I'm going to talk a bit about some actual practices that we can do for managing research data. Like, what does this mean in practice? How are we actually doing this on a day-to-day basis? What are we talking about in our data management plans when we're being asked to describe how we're managing our research data. Essentially, it comes down to two levels. Especially with digital research data, it's really about how are you organizing this in folders, and then how are you organizing your files. And you can sort of apply this to physical samples as well. If you think about, they have to be labeled, they have to have a labeling nomenclature and schema, they have to be physically arranged in a way that makes sense, not haphazardly. I think about 20 years ago, I was doing an internship where I was organizing DNA samples, well, blood samples in a free cold storage freezers, so I could take them out, put them on dry ice, alphabetize them, and then put them back, because when they got transferred to the hospital that I was working at, they, I don't know, got all jumbled. They were completely out of order. People had samples in different freezers that were for the same patient, and they had to be sort of like reorganized alphabetically. And I think it took me an entire year to do this as an intern with like a couple hours a week. So these kinds of ideas can be applied also to physical samples as well, where it's like, we will have them organized in these certain ways in these locations. So here's an example of a folder structure. This is a very high level kind of conceptual example where you organize your projects at the high level. Some folks like to organize it by, let's say they have many students working on projects. They might have a folder at the high level for their students. It depends on what kind of work you're doing and how collaborative it is, how many team members there are, how many lab members there are, if there are external collaborators, things like that. But typically, this is what makes sense for most projects. And you critically want to have your data all in one folder or all in one location, all in one directory if possible. And you want to separate that out by the raw data, the data that haven't been touched or analyzed or computed on, and then a copy of that you're working off of. The idea being that you can reverse engineer the results that are reported in an article by going back through these folders and sort of seeing where you started and how you computed or analyzed information and got to the point where you have a final data set that you work off of with the associated code or script that needs to go with that. And then you also have copies of the manuscripts or posters or whatever research output you're producing in this final folder called like paper or research outputs. So you have a PDF of those documents, you have the data set that was used to generate the findings, and you have the code or script that was used to clean or compute the data set. So that in 10 years, when someone asks you, where's that data for that paper, you say, I know exactly where it is. It's in that one folder. And I also can show you how I got there. I've also linked to the TIR protocol, which is a sort of template for reproducible research. This was developed over several years by bringing faculty members from different disciplines to a sort of retreat for 2 days. I did one of the first ones, so that's how I got involved in this. But this is the sort of final version of what was developed, which is to have a sort of like out of the box template for setting up folders for a scientific research project. So sort of discipline agnostic, but it should work well. What I like about this, I'm not going to go to the website, but if you did, once you have access to this, you can check it out. You can click on any of these links on the left-hand side menu, and it will tell you what should go in that folder. So I find this really useful, especially if you're trying to design a system or if you want trainees to understand how this should work. This is a good tool for just seeing, okay, what would be in this folder? What would be in that folder? What does metadata mean? What is in a README file, for example, those kinds of things. And then secondary to folders, so first there's directories, organizing information in directories, and sometimes you're collecting information from instruments where they're already sort of packaged in a certain way, and so you want to leave them that way, and that's fine. But if you otherwise have control over how you're organizing the data you're collecting, and how you're naming those files, then you would want to sort of adhere to these best practices if it's possible. So if you have control or if you have to name files yourselves, I recommend, or the best practice for file naming is to include a mix of information that would help you identify what's in the file without opening it. So that's the sort of criteria you want to use. Like if you saw this file in someone else's folder and they said this is data, would you know what it is? Or would you have to open it or not? So if you want to put the date of the creation of the file, I recommend using the international standard. It's the ISO 8601 standard for dates, which is year, month, date in digits, so not in characters. And the reason for this is that it can be read by most operating systems or computer programs as a date. Even Excel knows that that's a date, which I think is the threshold for knowing that it works well. So that's the recommendation. Um, I also recommend coming up with an acronym for the project. So if you work on many projects, it can be handy to have an acronym for each one that you label the files with so that if for some reason files get moved around, you know where they should actually belong. I recommend if you're working on a team or if you have trainees to have them put their initials on the files that they're collecting and that they're responsible for. I have had a situation where I've been asked to help researchers organize their files and we've gone into their folder, we've gone into their data, their servers, or wherever they're hosting their data. We've looked at folders and there's like an untitled folder and it has a bunch of work that some student collected, but it's not clear which student collected it or what they were doing. And there's no like metadata around the files to let us know who actually did that work. So this happens more common than you would think, and that's fine. But I think a way to get around that and to mitigate against that is to have people get in the practice of like sort of tagging the files they work with their own initials. Especially if you have some like qualitative data like interviews, it can be helpful to know who conducted which interviews. So one handy way to do that is to just put the initials of the person who did the interview in the name of the file so that when you're looking at all the files, you say, so-and-so did that interview, so-and-so did that interview. And you don't have to open it to see. It can be handy to have a topic if about the file if you're working on multiple things. So these are kind of all optional. It depends on what you're doing and what would make sense in your project. And then finally for versioning. So instead of putting a new date on a file, the best practice is to version it using a sort of sequential digits like 001, 002, etc. We're sort of trying to avoid any special characters except for underscore or hyphen because some special characters are read as delimiters by certain programs or systems. And a delimiter is like a break. So you're reading in a file, and then some systems might say, oh, a period. That means the file is done. I'm not going to read the rest of this, or I'm not going to print the rest of whatever it is. So it can cause some headaches when you're working with certain kinds of programs or systems or programming languages. So to avoid that, no spaces, no special characters, anything like that, except for hyphens or underscores, and even periods. So we used to version files by like 1.2, 2.0, and we're trying to move away from that and just use sequential numbering. So it does require that you sort of anticipate how many files you'll collect in a series. So if you're going to have thousands of files, you would use like a much longer leading zero number of leading zeros than if you're only collecting dozens of files in that kind of category. But other than that, that works well. And just a note about like how it can be helpful in terms of figuring out a schema for naming files. So it allows you to easily sort files based on a criteria. So let's say you want to sort your information chronologically. In most computer operating systems, you can do this with your sort of file explorer tool. Like it knows when the file was made, so it can do that on its own using metadata. Some programs will strip file metadata when you save them. It means it'll remove the date the file was created, and so you can't really rely on on the data collection tools necessarily to like maintain that connection, which is why it can be helpful to put the date yourself in the file name, and that will allow you to organize them in that way. You can do it by type, so if you have notes, if you have questionnaires, interviews, or by participant, for example, you could have their participant IDs as the first part of a file, and that would allow you to sort them by the participant. You can also force order files with numbering by putting leading numbers at the beginning of the file. This can be really helpful in Microsoft products like SharePoint or Teams. If you're storing files in SharePoint, I don't know if anyone has noticed this, but it alphabetizes files. It doesn't, so if you create folders or files in SharePoint, instead of putting them in the order that you create them, it will alphabetize them. So if you put leading numbers, it will force it into the order that you want, basically. So that's one way to do that. And the final sort of best practice is to keep a README document associated with each project, or even it could be the data set, or it could be at the file level, or at a sort of collection of files within a project or within the data set. And basically, this is a sort of what we call part of doing good documentation or keeping metadata. Often, when funders ask for a data management plan, they're going to have a section where they ask you to describe any metadata or documentation that you're doing during the project. So this would be a good example of something you could talk about in that case, which is, for the humans participating in the research who are working on the research or are the researchers themselves, this is a really useful document. It's not machine readable metadata, which I'll talk about, which is also useful to have in certain contexts, but this is for like humans who might need to interact with the data set. And it's really for if you're the PI or a co-PI, it's for yourself as well. So that down the line in many years, if you have to go back and understand what you did with a project, you have a very clear document outlining all the workflows, processes, decisions that were made about how to name files and how to organize the directories or the folders. So basically, you would want to have sort of one of these documents that just lives by itself. If you think of your project as having a folder and then some subfolders, this document would live as the only file in the project folder, the high-level project folder. So it's just, certain subfolders like data, research outputs, and then this one file. And it would ideally have things like the location of files, the location of the data that you're collecting. It would have the structure of the folder system. So you could have a sort of diagram of your directory structure or an explanation of it. And things like the schema for how you're naming your files. So the information about how you decided to name your files, and things like a key for abbreviations. So you could have a list of all the abbreviations you're using and then have a key for that. So I'll show you what this looks like in practice. And I have a sort of Word document version of this in one of my RDM guides. So if anyone wants to take this and use it as a template, I'll show you the link at the end of the talk. But you can feel free to do that. So basically, one exercise I do with researchers is to have them create a table with a list of all the types of files they're going to collect. So it can be images, it can be physical samples, it can be code, it can be text, it can be a spreadsheet, whatever it is, just all of it. And just thinking more about like categories of files or categories of data. So images could all be one unless you have different kinds of images that really need to be treated differently. So you would say in this case, like the type is a microscope image. And then the schema it's going to be the date underscore the microscope underscore and then the image number. And then you would critically need to have a key. So like, what do we mean by date? So we would put the date of the image capture in that ISO 8601 format, right? The International Date Standard. The microscope is the name of the microscope used. So they have names. And then the image number is written in sequential formatting 00x. So you would just number them in that kind of way. And then critically an example of that file name. So you have the date, microscope 53, and then 001.jpg. So that's our example. This can be handy as well if you have trainees you're onboarding. So if you have students or other staff who are working on the project who might roll on or off projects over time, you can just send them to read this document and say, if you're collecting this type of data, just make sure you name it according to the schema, and then everyone is doing it the same way. And that sort of produces this really nice, organized version of files at the end of the project. So I want to just spend a little bit of time talking about extra considerations for human participant data. So if you're collecting human participant data in whatever context, normally it's the same kind of considerations we would have for health context versus other kinds of contexts. And talk a little bit about thinking through statistical disclosure risk and how do we assess that and talk about it in our data management plans and when we're thinking about planning for working with the data and then creating a version of the data that can be shared after the project is finished. So even if we're creating an anonymous version, how do we know it's anonymous versus just de-identified? What's the threshold for that? What are the sort of conditions and what does that look like? So there's no best way, but there are some standards. So, for example, let's consider we have this de-identified data set on media habits. We have the person's age, we have their gender, we have, for some reason, their postal code, their very specific postal code, and then how many hours a week they watch Netflix. So you can see that there's someone who says she watches Netflix more than 60 hours a week. So she might not want people to know that. So just, it's not very sensitive, but it's a little bit sensitive, right? And this was, I think I came up with this during the pandemic when I was watching a lot of Netflix. So that was on my mind. Let's say we also have separate from this data set. So this is, a research data set, but then there's also this volunteer public directory. So Stephanie Gingras, she volunteers for some organization and their directory is public. It has her address, it for some reason has her gender, and it has her, for some reason, her year of birth. Which probably wouldn't be in a public directory, but anyway, it could be in some kind of directory. So if we look at these three demographic items, we could match them to the three demographic items in our data set. Using other kinds of data, we could confirm that Stephanie is the only 77-year-old female in this postal code. So then we would know that it's her response in this data set. Um, so this is sort of pointing toward a statistical disclosure risk assessment called K-anonymity. And if you're not familiar, it's basically a way to statistically analyze your data set to see how many observations you have that have the same demographic criteria or some criteria about them. So it's saying like, it would say Stephanie's observation, the first highlighted row of the media habits data set, is the only one in that data set with that combination of demographic variables. So of that combination of age, gender, and postal code. That would give you a sort of like very poor rating on that K anonymity um, um, test. So that would be like of one. So if you have one as the result of the K anonymity, it would show there's like people in your data set where they're the only ones with those criteria. So a best practice is to have it at 5, meaning there are 4 other observations with exactly those same combination of demographics. And in that way, it would be really hard to know who is which observation. So that's a sort of, arbitrary standard. And we have to keep assessing whether that is still good enough for not figuring out who a person is in a data set. But that's one way to know. So you want to make sure you have variation across the observations for those combined demographics, those sort of identifying factors that you might have about people. There's also a statistical test called L diversity. So it's one thing to have just one person in your data set with a combined number of demographics. It's another when you have someone with the same demographics. Let's say we have 3 people who say they're female, live in Montreal, and are in the age range of 90 to 100 years old. So that's fine. Now we have 3 people. Our K-anonymity is 3. It's not that high, but it's not the one single person. But unfortunately, they all watch the same amount of hours on Netflix. They all watch more than 60 hours of Netflix a week. So let's say if we meet someone who's female, who's 95 years old, and who lives in Montreal, and we know that there's not that many of them, we can be almost sure that they watch a ton of Netflix, that we know what that answer is. So you also want to look out for the fact that you have variation in your across your variables as well, across any of the items, the measurements you're taking about participants. So it's across observations and then across each measurement as well. So it's 2 dimensions that we have to be careful of. I also wanted to talk about aggregate statistics. So I think a lot of folks in their data management plans or just in general have this notion that, well, if I report only aggregate statistics, nobody can figure out who my participant is. So I just wanted to note that there is, in some cases, ways to reverse engineer individual people from aggregate statistics, and it's something else to just be aware about. And, talk about if this is a concern with the data that you might be collecting. So here's an example of a class that has 5 students. The teacher writes the average exam score on the board. It's 85%. So that's their average. One student moves to another town and drops the class. Now the class has 4 students. The teacher writes the new average on the board, 84%. Has the student's privacy been violated, the one who moved? And I'll just tell you that yes, they have. So with some sort of very simple algebra, we can figure out that the student who left, their score was an 89. So even though the teacher only put aggregate statistics, because we've removed some people, we can then, with that remaining information, deduce what the person's score was. This is a very simplified example of how this might work in a larger data set or with, other kinds of context around it. But just to say that, even if we're only reporting aggregate statistics, it doesn't necessarily prevent the identification of individuals. So yes, the teacher disclosed the student's exam score to the entire class. Releasing statistics can tell us information about individuals. So one technique that folks use is to add noise. So this is one anonymization technique where they add sort of fake data that doesn't affect the overall analysis or the descriptive statistics about a data set. And this has to be done usually by a statistician or someone with that expertise. So this is one technique to prevent this from happening. But just in general, what are these important considerations? And these are things that, are considerations in particular for folks working with human participant data. And this would be an expectation if you're writing a data management plan or if you're thinking about data management is how all of these techniques, how are you going to anonymize your data set? What are you going to do specifically? Who is doing it? Do they have this expertise, a statistical expertise to do this? Because it is meant to be done in a way statistically that requires a statistician or someone with that expertise. So where there's always this balance between privacy and the usefulness of the data. So the more you strip out information from your data, the less useful it might be. And then also thinking about what's the impact of the anonymization technique. So you want to make sure you're checking the descriptive statistics before and after you add noise or remove variables or remove observations, because if it affects the sort of analysis, then it's maybe not going to be a good sort of practice to implement. You want to also compare relationships between variables that you need to analyze to answer your research question. So just all this to say is that anonymization is an ongoing process and something that is starting to, there's more of a spotlight on this in terms of data management and planning for this. You usually do need to combine multiple techniques and approaches, and data management planning should detail these processes. This should be really detail specific, so not high level, but really like what technique are you using? How are you going to prove it's anonymous? Or prove that you've at least lowered the re-identification risk to a point that's, hopefully negligible. But there's no method that can eliminate all that risk. So it's about doing good faith work to reduce it to an acceptable level. And as technology becomes more complex, it becomes easier to reconnect people using other kinds of data sets out there. I hate to bring up AI, but this is something that generative AI, when it's trained on lots and lots of data, could make these kinds of connections in ways that we had not been able to in the past or we had not anticipated in the past. So it's maybe necessary to build into planning revisiting data over time to make sure it's still anonymous or still at that level, that low acceptable level of being anonymized. Finally, I'm going to talk about ways that sensitive data can be shared. And there's a big misnomer here because it doesn't mean that it will be shared. So ways that we can share data and sort of align with these best practices around data sharing, even if we have very sensitive data that really can't actually be shared. So this is to contrast open access data. So in open science, there's this big movement for open research data, and that means it can be freely accessed, reused, remixed, and redistributed with absolutely no restrictions. So in many cases, this is not a good fit for data that's been derived from humans in any kind of way. Unless it's like very difficult to identify a person, or it's so large, the data, that it would take too much like resources and money to do it. In that case, you might say it's fine, or if it's stuff that's publicly available anyway. Here's where we bring in the FAIR principles. So if we're aligning with the FAIR principles, we could be said it could be said that we are doing open science as best as possible in the context of working with sensitive data. So the FAIR framework is a sort of best practice that came out in 2016, so 10 years ago now, actually. It was published, I want to say Nature or Science, and I always blank on which one it was. But it was this idea of having a framework for making data as open as possible, but as closed as necessary. So you could have completely controlled access data that's in a biobank, for example, and it could be fair. So these two things are not mutually exclusive because fair is really that you can find the data, you know where it is. It doesn't mean you can find the actual data set. It means you can find where it lives. And that it's accessible, and that doesn't mean open access, that it's interoperable, and that it's reusable. So I'll just quickly go through what each of these mean. So there are some like technical criteria. So this F1, F2, F3, F4, these are the sort of criteria on the FAIR project organization site. I have a TLDR, which is too long, didn't read, or like that's too confusing. What does that actually mean? So I have a sort of cheat sheet explanation. So what is findable data? It means that the data should be in a repository. That can be a biobank. That can be that can be a controlled access repository, but it should be stored somewhere that has the infrastructure to be indexed in search engines so that when you go to Google and you search for data about something, you find that it's in that repository. Most repository infrastructure is indexed in search engines. So that's part of the purpose of that repository infrastructure. It should have documentation, including metadata, so it should have some information so that people can figure out that it is the data that they're looking for. And it should have a persistent identifier or a PID. So the same way we assign a DOI to an article, a data set should have a DOI. And that's telling everyone that that is the authoritative version of that data set. If the data set moves locations, the persistent identifier, the DOI, will always point to where that data set is located. So in terms of what repositories we have available, so in Canada, we have less options than in other geographic areas, and that's to do with our privacy regulations being stricter than many other places. But we have a data repository at McGill, the McGill Dataverse, and it's open to anyone at any affiliated hospital as well if you want to deposit data there. It can only take non-sensitive data at this point. There are some pilot projects in process to allow at some point for more sensitive data to be deposited in both the Dataverse and also at a Canadian level data repository called FRDR, or the Federated Research Data Repository. So those are two options that have local storage in Canada. And are sort of fully governed in Canada. But at the moment, those are still in pilot phases. And then there's other domain-specific ones. So if you're working in specific medical fields, there is probably a repository specifically for data in that field as well. So what is meant by accessible data? So this doesn't mean the data themselves should be open access. It means that they should be in an open or public-facing repository, meaning you can get to the web page that describes the data. So the data don't necessarily have to be downloadable or accessible to anyone. They just have to be on a site that's accessible to everyone without a login, for example. And then the metadata about those data need to be both human and machine readable, meaning there should be an abstract to describe the data set so people can understand what the data is about. Are those free repositories? I'll go back one slide. So McGill Dataverse is free. It's part of the Borealis Dataverse. It's a Canadian Dataverse. It's free to researchers. We're paying for it as a library to subscribe as part of a consortium of Quebec University libraries. So each university in Quebec has their own version of this. FRDR is free for all Canadian PIs, so you can create an account and then you can deposit data set in the Federated Research Data Repository. As of now, most of these are free for a certain level of data. So once you have large data, the rest of the ones that are listed here tend to have a tiered pricing model where if you have like many gigabytes of data or getting into terabytes, then you might have to start paying. But we do have those two free options, which is the McGill Dataverse and the Federated Research Data Repository. So that was a good question. So accessible data should have metadata that's both human and machine readable. So human readable metadata, again, like an abstract, and machine readable things like the title, the author, the keywords the associated with the data could be in a sort of controlled vocabulary. So a lot of medical fields have controlled terms for whatever you're working on. So there's colloquial ways of talking about something, like I have a cold, and then there's a specific term that's used for that, whatever that virus or whatever that person has, that would be used in the medical sense. So that would be the term you would want to use so that when it's indexed in a search engine, the search engine can find all the related material to that item. And again, so here are some examples. A human readable metadata would be things like the description of the project, any notes. They would normally not really need to be in a structured format. They could just be in a text document. Machine readable metadata are things like your ORCID ID. So if someone searched for you as a researcher and you had an ORCID ID, Google would find anything that was linked to your ORCID ID, and it could do that automatically without humans intervening in that process because it's a machine readable metadata. CSV files are machine readable, they're comma separated, so machine understands that every time there's a comma, there's a new value. You don't have to tell it that. Creative Commons licenses are machine readable, so when you go into a search engine or into a data repository, you could filter by the license applied to a data set. You could look at only open ones, or you could look at only ones that could be used for non-commercial purposes. That ISO 8601 date format is machine readable. Machines understand that's a date. You don't have to do any work to tell it that it's a date. Oops, sorry. Interoperable data, this is the tricky one, but it's actually not as complicated as it looks. It really means data should be in an open file format, so not a proprietary file format, like things like CSV, or text documents. Metadata should also include machine readable standards. So some of this stuff comes up over and over again. It also means that if you are collecting information about a certain kind of variable, that if there's other data that exists about that variable, you should be able to merge those two data sets together. That you should be able to combine data sets that have a similar or the same variable. So if you're, for example, saying you have postal codes, if there's another data set with postal codes, those should be able to be matched because you wouldn't, you wouldn't, I don't know, come up with a different way of putting postal codes. This can be trickier when you have things like cities where people might spell them differently or use different, if you don't have, if you're not describing a location in the same way, then you might not be able to merge them. So it's sort of getting at using the official terminology for places or for different things in order to make it combinable with other data that's about the same topic. So just a note about what's a preservation file format. So these are open file formats that make data interoperable, meaning you can open it in many software programs without needing to pay for the software. So things like CSV or tab for spreadsheets, RTF or text for text documents, TIFF or JPEG for images, things like that. And so what is reusable data? And I think here's where people get hung up in terms of like, I don't know if like, no, I can't make it so that everyone can reuse my data. There have to be some restrictions on the reuse of this data, and that's fine. So reusable doesn't mean that you have to let people reuse your data for anything. It just means it needs to be clear what people can do with it and how they can reuse it. So it should have terms of use or a license. So it should have information about the origin and version history of the data so that people can understand which version they're using and they should know what they can do with it. So you could have a closed license. So I'll show you some examples. So CC0 and CC BY are considered open licenses, meaning anyone can take that data and do whatever they want with it. The exception being in CC BY that they have to cite you, but it's still an open license because they can still do whatever they want. Then there's sort of more restrictive licenses. So there's non-open licenses like the non-commercial license or the no derivatives license. And that's also fine. Your data would still be fair if you used a closed license, so it's just as long as people can know what they can do with it and what are the restrictions on the data. And just I wanted to make a note about working with Indigenous data, so data derived from Indigenous communities or from Indigenous land, that there's a separate framework for this, which is called the CARE principles. And this is high-level Indigenous data, like globally. We have the local Canadian context called OCAP, which applies in some contexts with some communities, but the general one is CARE. So just wanted to make a note about that in case that's relevant, and I've linked to those documents as well. And a note about the OCAP course that is offered by the First Nations Information Governance Center. It's an online self-paced course. So if anyone does work with Indigenous data, this could be a good primer for what are the expectations or sort of best practices in the Canadian context, in specific contexts with First Nations in particular. And then I wanted to end with just a checklist for FAIR data. So I think it can be hard to look at the FAIR principles and know if you're actually aligning with them. So I've included this checklist, which will kind of tell you, like, if you can check all these things off, your data could be fair. And this is information you could put directly into a data management plan. So if you need to talk about making your data fair in a data management plan or making it available, you could discuss these criteria and how you're going to meet them. Things like, is it in an open and trusted repository? Does it have a registered DOI? Is it in standard or commonly available open formats? Is the data or metadata retrievable via an open search protocol? So the data don't have to be downloadable or findable, but the page about the data has to be somewhere on the internet that someone can find it. And then there's a set of criteria also about the documentation for the data set, like README files or metadata. So like, are there licenses? Does it include machine readable standards where possible, like the ISO 8601 date standard, etc.? And just one final note about depositing sensitive data. So what's the situation now with like sensitive data? And the majority of sensitive data that we're talking about that comes from research context is data derived from humans. So personal data that has personal information or is so sensitive about a sensitive, vulnerable population or has personal health information. So the ideal would be you would have a public data repository, meaning you could find the data repository online just by searching and you could access it without logging in. But that repository would have access controls, meaning you couldn't access the data and the data would all be encrypted and have zero knowledge encryption, meaning you wouldn't be able to access the data and the repository itself couldn't access the data. And there would be some process by which someone could request it and then either a data access committee or the researcher could approve or not approve. And that process happens external to the repository. So that would be ideal because then, you'd find it and it would be fair and you would still have the control. Right now, we have some workarounds, which is things like you create an empty page on a data repository, so you don't upload the data, but you have a page that fully describes the data set, and then you have information about how someone could request access to the data outside of the repository. Or another workaround is sharing a fully anonymized version of the data set openly. And then there are things in the pipeline in progress, such as a controlled access management for research data pilot project that's happening now with the Federated Research Data Repository. And McGill is participating in this pilot. So this is sort of TBD over the next 2 years is the timeline, but there may at some point be a sort of centralized Canadian option for researchers that would work in the Quebec context as well. So UDEM was one of the initial pilot partners that sort of developed the pipeline for this, and now we're moving forward to the second phase. And just an example quickly, I linked to the COVID Immunity Task Force. They have a lot of their data in the McGill Dataverse, so you can see what it looks like. They have 2 collections. They have a controlled access data bank, which basically describes all the data sets, assigns DOIs to the data sets, but then directs you to access them through the Data Access Committee via an external website. Then they have their open dataverse that has fully anonymized data sets or data sets that don't have any personal information. And I'm including a list of resources about research data management at McGill that's also available to the public as well. And I'm happy to take questions. Sorry, there's only 5 minutes for questions, but I'm happy to take questions. And if anyone has any specific they want advice about specific repositories for their own research, or they want me to review a data management plan that they're submitting, I'm happy to do that. That's part of what my role is. So you can also feel free to reach out after this directly to me. Okay, I'll take questions.